Lesson 84, you guys, is all about words and not really much about numbers at all. And that could be good or bad depending on how you feel about it. We don't even have variables. It is all about concepts. So, the first concept that we're going to talk about is degrees. The degree of an equation. And then we're going to talk about solutions to systems of equations. It's not that hard, and we get to draw pictures, so that's good. First, let's talk about degrees. Here is what a degree is. It's the exponent on it's the highest exponent, on the variable in a term or an equation. So, for example, if we have x squared plus x plus 1 equals 7, the degree of this equation is 2. It's a second order, or a second degree term, because the highest number is 2. If we have 3x cubed plus 4, the degree of this expression is 3. It's a third order expression. Okay? The only trick is that if you have, say, 2, well, that is technically 2 times x to the 0, right? Because x to the 0 is 1. So this is considered a 0 degree. I'll just write these down. This is a second degree. You can see it all the way to the edge. And this is a third degree. It's not hard. It's just a concept to throw at your brain. So that is just information for you. Degree refers to the degree of a term or an expression is the highest exponent. Okay? 84b, so that's A. Boom, done. That's A. Here's B. B is a little more interesting. We've talked about having systems of equations, and that is 2 different equations that have a similar solution. Ooh, my paper's crooked. I hate that. There, that looks a little better. So what the deal here is that when you graph a system of equations, there are 3 possibilities. So I'm going to write that down. When you graph a pair of equations in a system, S-Y-S-T-E-M, 3 possibilities exist. All right? And we're going to draw little pictures of each one of them. Okay? The first possibility, and we're going to draw our little graphy doodle here. Okay? The first thing, and in our experience, the most likely thing, is that you'll have one line and another line. And they will cross in one point. Okay? So in this example, our lines cross in one point. Right? Okay? That's typical. And by the way, that would be the location of our x and y that make both of those statements true. Okay? So, that's one possibility. The second possibility and you'll see these pictures are in the book on these 2 are on page 346. So I'll just jot that right here. I'm working off page 346. Okay? And this one is considered A. They're labeled in the book. The second possibility is that they're both the same line. Okay? So they don't just cross in one point. We graph twice, but we find out that we get same line, all points the same. Doesn't happen that often, but it can happen. That's the second possibility. And then the third possibility, when we graph 2 equations in the same system, they might run like this. Pretend my lines are parallel. They might be parallel. They will never cross over, but they're two different lines. So that is what we call parallel lines no point in common. Okay? Pretend my lines are perfectly straight. If they're wobbly, they might eventually meet sometime. But we're pretending that ours are perfectly straight and they're never going to cross. Now, we've got some special names that we're going to put on these. If a system of equations has at least one solution Sorry, I'm just looking at the book because the words that they're using don't really make that much sense to me. If it has at least one solution common to all equations, then they're called consistent. So, I'm going to cross this out so you don't get confused. This is considered a consistent system of equations because it has at least one point that they share. This is considered also consistent because remember we have two lines. Consistent. These are two lines on top of each other, so they share at least one point in common too, don't they? This is the one that is different. This one is considered inconsistent because it has no points in common. So the test for consistency is, do they have at least one or more point in common? One or more points in common, consistent, consistent, inconsistent. The other word that we use to describe them sometimes is if. We use a word called dependency to describe the fact that the line is exactly the same. If all the points are the same, then this is considered a dependent system. One line depends on the other. If all the points, if all the solutions are on the same equation, then we call it independent, and then these would be independent. Now, this is vocabulary. We're not doing any calculation. We're not really going to use those words too much for calculation. Honestly, I'll tell you this. Most students have a really hard time keeping these ideas locked in their heads, and I will tell you what else. They're not that important. Don't tell John I said that, but they're really not that important. You're not going to see these coming up again and again. You probably won't bump into them on any SATs or anything like that. But just be aware that we can use these words, consistent and inconsistent, independent and dependent, to describe systems of equations. And this is fairly important, the idea that we can have three different kinds of pictures when we graph two systems of equations. Otherwise, just kind of tuck this away in your brain, that there are these special words that we can use to describe them, and remember that they're in lesson 84. For the homework, they ask you to graph a pair of equations and then decide if they're consistent or inconsistent, dependent or independent. Look at these pictures on page 347 and page 348. You might want to do this together right now. Do the practice problem. There's just one. You might want to do it as a class together so that you can kind of sort through it and figure it out together. All right? Enjoy your homework. See ya.